All right, people, we're going to talk about the shapes on your shape sheet. Now, first of all, first thing about your shape sheet is mark off trigonal bipyramidal. You don't have to know that one, okay? Mark that one off right there. All right, grab your sheet because it'll help you. All right, so this is your shape sheet. And I'm going to post this for the kids at home. You can print it. So everybody that's in this week's class is getting it today. Everybody in next week's class will get it on Monday. So if you're in the other one, you're going to need to print this or just keep referring to this picture. Make sure you download this picture so you don't have to go back to your Google Classroom every time, because they're going to be using these shapes, okay? Now, what I have is some toothpicks, and these toothpicks are going to represent bonds, okay? And mostly they're going to represent covalent bonds, because these shapes, most of these shapes that we're going to be talking about are molecules, okay? So these are shapes of molecules. Not all of them, but most of them. All right. First thing, the first shape is super duper easy, okay? The first shape is linear, okay? Now, you know from being in algebra or geometry that if you have 2 points, the only way to connect them is what? A straight line, right? So if you have 2 atoms and they're connected by a bond, then they have to be linear. There's no other way to have these 2 atoms connected by a bond and it not be linear, right? This looks like a little bar my hamster could maybe work out with. Anyway, an example of something nice and straight like this could be HCl, hydrogen and chlorine. Does that make sense? So it's got to be a straight line. There's no other way. There are also other linear shapes. You could have 3 molecules or 3 atoms. That was the wrong word to say. You could have 3 atoms, and they could also be in a straight line, okay? And good. So you could also have a linear molecule that looked like that, okay? Now, would you say that a line, would you say that was, or something like this, would you say this is a 2-dimensional or 3-dimensional? Yeah, it's 2-dimensional, that's right. We're going to think about this as a 2-dimensional object, all right? Okay. Now, the third shape right here is called trigonal planar. Now, we all want to say triagonal, right? And trigonal does mean triangle, okay? But the word's just trigonal, it's not triagonal. A trigonal planar molecule is one that has 1 atom in the middle and 3 on the outside. But see the next word where it says planar?
Ninth graders with the last name Rackley to Rosetta, please go to the auxiliary gym to get your pictures taken. Ninth graders with the last name Rackley to Rosetta, go to the auxiliary gym for your pictures.
All right. So this right here, this flat triangle, is a trigonal planar. You know the word planar means on the same plane, right? Like a sheet of paper is planar, right? Right? Or the piece of the machinery in the wood shop that flattens out the rough wood is called a planer, okay? So let's look at this trigonal planar shape, okay? And let's talk about it real quick, because now there's a term, some terms we have to use. This atom in the middle is called the central atom. It's the central atom. and then the atoms on the outside, on the perimeter, they're called the peripheral atoms. So you have a central atom and 3 peripheral atoms. Okay? So this is 2D. When I talked to you about how many dimensions, well, I call this a 2D shape, all right? Because it's flat here on the table. It's a flatlander, okay? All right? The next shape on your sheet says bent or angular, and there's 2 little bumps. We're going to talk about those 2 little bumps on Monday, okay? Those 2 little bumps are extra pairs of electrons that are not stuck to other atoms, okay? They're called unbound pairs, and we'll start talking about that on Monday. All I need you to know right now is that you can have 3 atoms, and they can make this shape right here. And this is very simple. This isn't linear. It is, ready? Bent. Does that make sense? This is the shape of a water molecule. This is the shape of a water molecule. It's bent. This is 3-dimensional. And you're like, no, Mr. Perkins, it's laying right there, but watch this. Watch what happens when I start messing with it. Wow. If we look, if I spin this thing in a circle, a bent molecule is 3D, right? Looks like a crankshaft going around, doesn't it? I know that's what y'all are all thinking. But look, what if it was linear and I spin it around, it's still 2-dimensional, right? Does that make sense? It's just like a drive shaft, but the bent one is like crank. So bent molecules are literally just bent, okay? And they have 3 atoms. Okay. The next shape is tetrahedral. Tetrahedral. And I'll have bigger marshmallows here on Monday, but I'm just gonna call this one big marshmallow right here, okay? One big marshmallow. Now, a tetrahedral shape has a central atom in the middle, okay? And it's got 4 peripheral atoms. And here's how those peripheral atoms, you can't tell in the picture, here's how the peripheral atoms are laid out. You have a bent molecule in one direction, okay? And then 90 degrees to that is another bent molecule, basically in another direction. Of course, this is just one total molecule together. But this is tetrahedral. It's kind of like a jack. See how we have a V on this plane right here? And then there's another V on that plane right there. Does that make sense to you? So it's not just sticking straight out in 4 directions. It's a V like that, and then another V like that. So one thing you may be thinking is that tetrahedral means that there's 4 outer atoms, but that's not what tetrahedral means. Tetrahedral means 4-sided. That's where the hedral comes from. So look at this. If I had this and I set this molecule down, I could set it on this side, could set it on this side, or this side. It's got 4 different sides that you could rest it on. Does that make sense? It's not that it has 4 atoms that are peripheral. It does have 4 peripheral atoms, but it's named tetrahedral because there's 4 triangular sides. 1, 2, 3, 4. Does that make sense? All right. The next shape is trigonal pyramidal. Okay. Now look on top of your trigonal pyramidal. That's not an atom up there. That's another unbound pair of electrons. okay? Trigonal means triangular. So here's what that looks like. Boop. Do you remember the shape? Check this out right here. Remember the shape that we originally had that was trigonal planar? Right? Here's what trigonal pyramidal is. There's still one atom in the middle, but check this out. Beep, boop, boop. It's up here. Now this object's three-dimensional. Trigonal pyramidal literally makes a Mayan pyramid. Didn't the Mayans make pyramids that were triangular on the bottom? And the Egyptians made pyramids that were square on the bottom? This is a trigonal pyramid, right? Trigonal, triangular-based pyramid with the big atom on top. So trigonal pyramidal. And then the last one is octahedral. Take a look at your octahedral. Octa means 8, right? What does hedral mean? I just told you. Hedral means sides. So octahedral, the octahedral shape has six perimeter atoms, 6 peripheral atoms, not 8. But now this is what it looks like, okay? And you should probably know that these atoms, you probably already realized that all these atoms are just trying to stay as far away from each other as possible, right? So this is the tetrahedral shape. It's got 6 peripheral atoms, and they're shaped like this. But octahedral means, I hope I haven't been saying tetrahedral. Octahedral means there's 8 sides to this. So if you look, there's a side, a triangular side, we could sit it down on. 2, 3, 4, 5, 6, 7, 8. It's got 8 sides. Having 6 peripheral atoms gives you 8 triangular sides. Does that make sense? 1, 2, 3, 4 on top, and 1, 2, 3, 4 on the bottom. If you can imagine a triangle right there that we could set this thing down on. So octahedral only has 6 peripheral atoms. And that's it. Those are what the shapes look like. We'll do more of this on Monday. But that's your quick introductions to the shapes. That's your molecular shape sheet.